Let's continue about the data link layer and the local area network that we have first lecture in last week. From this slide, we need to think about the data link layer overview, and then the role of data link layer, and we need to think about the sub layers, that is logical link layer control, LLC, and media access control sub layers. Also, it is necessary to understand the why we need the multiple access, because of we are sharing a link, so multiple access devices need to content control method are needed. And from these basic principles, there are many LAN protocol standards are developed. So we need to understand some representative LAN protocols that are widely used in the world. And the other part is that basically the data link layer is very important because it composes the frame from the bit detection. So the flow and error control is definitely necessary to receive the frame between nodes. So we will learn about the concept of flow control and error control in data link layer. Basically, we need to think about the link that is shared between two devices. That is we call the point-to-point connection. But generally speaking, in the local area network, usually one physical link is shared by many network devices. So we need to resolve the issue of media access to the link. So the in the broadcast link, the data link layers are device two part. One is that data link control. So we call this DLC sublayer, and the media access control sublayer. We are call this MAC. And from this different concept, actually many local area network standards are developed based on the media access control method. To create the RAN standard, actually that project was carried out by IEEE. That's the Institute of Electrical and Electronic Engineers, a kind of professionals association in America. Actually, this is now expanded all over the world, and they started the project 802. So this Senate committee handles to the computer network of the local area network and the metropolitan area network. And from this project, when we compare the OSI model and with the 802 project, only the data link part was significantly different. For example, in OSI 7 layer, we call that data link layer, and from this standard committee, they devised two parts. One is that media access control sublayer and logical link control sublayers. If we look at that structure more specifically, for example, like um, among the 802 project, the one chapter is 802.1 that describe the internetworking between networks. And then most of the LAN standards are defined according to the 802.2, and several different media access control mechanisms are categorized according to the protocols. For example, 802.3 we call this CSMA CD, and another name is Ethernet. Now we call that Ethernet. And then 802.4, that's the token bus, and 802.5 is we call that the token ring, and the other many different local area network standard are devices from the project 802. And comparing with the OSI 7-layer model, actually in the data link layer, they are handling about the logical link control part and the media access control, and the physical access, actually physical layer are covered according to the each protocol. They have their own um, physical connections or electric definitions are devised. In your book, from page 361, there are some descriptions of the wired LANs, the wired local area network. Especially, it describes the Ethernet. And the main issue that we have to understand that is that the addressing scheme of the Ethernet. In the Ethernet scheme, the addressing is very important because each station on the Ethernet network uh, has its own network interface card. As we call that this LAN card. Maybe you are handling some of this LAN card. And among the addressing scheme, the Ethernet card has 6 byte physical address. We call this MAC address. For example, 6 bytes, that means that we have 6 hexadecimal numbers there, right? And then, for example, like 47 is we divide 4 bits, so 47, and then like 20, like 20. So each from the hexadecimal address, we can um, figure out the binary numbers using 4 bits of each 1 byte. And then this signal will be transmitted through the network. And as we already learned from the signal part of the transmission, actually the Ethernet case, the electrical characteristics baseband system, that is they are around like a 10 megabit per second system. Okay, and they use the Manchester digital encoding. But for the broadband system, that they are the data speed is more high, then they use different um, digital encoding schemes, such as differential phase shift keying. And the Ethernet network data speed is around 1 to 100 megabit per second, but mostly now uh, the 100 megabits per second of the transmission speed is widely used. So we say that the legacy network, legacy LAN, usually it transmit like 10 megabits per second. Okay, but nowadays it expanded like 100 megabit per second. If you refer the page 366, okay, 366 and 367, you can see the address, the MAC address of the Ethernet in your book. So if you look at the page 364, you can see the Ethernet frame. The Ethernet frame contains 7 fields. I already explained this to you in the face-to-face lecture. One part is that the destination address and the source address. These are 6 bytes. Why 6 bytes? As we've seen from the previous slide, this is the MAC address of source computer and destination computers. So they use a 6-byte destination and source address. And then the second part is that the type. The type, this field define the upper layer, upper layer protocol. For example, like IP or ARP, that is actually the network layer protocol, right? So this kind of protocols are converted into binary numbers. So the frame also figure out which layer actually use this one. And then the CRC code, this we call as a check, no, it's a cyclic redundancy code. We will learn this later for checking the errors of the frames. Okay, and then the data and the paddings are included. Actually, data comes from the network layer, right? And then it is encapsulated. What is the padding? Actually, we know that the minimum frame length should be 64 bytes according to the Ethernet, the schemes. So if we the data size is not big enough to compose the 64 byte, including all these header information, then we need to some meaningless padding to put there. Okay, and in addition to this frame type, we need a start of frame delimiter that notify that now the frame start. Okay, so it has a type like 10101011. This kind of bit indicate that now the frame start. And then it also has some preamble, 7 byte of preamble that alternating zeros and ones that alter the receiving system to the coming frame and enable it to synchronize it. It is very important. Okay, synchronize its clocks, the receiver's clock to so it can correctly recognize each bit. This is actually the type of the Ethernet MAC frame, and minimum payload could be like 46 byte, but maximum payload about 1500 byte. Okay, so if we use the Ethernet in our organization, usually this type of frame is exchanged between nodes. So we can abstract this frame structure like this: header part, and then data, and then trailer. So trailer could be like used for like error checking. So this in this case CRC, and header part of this part. In page 371 figure 13.7, you can see the 10 base 5. Okay, say 10 base 5 Ethernet implementation. Okay, so suppose if you want to install the Ethernet local area network in your schools or your organization, how we can use that? First, you need to understand that 10 base 5, what does it mean? It is that the speed of the link 10 megabits per second, and this is a baseband. Okay, and this one segment size is like 5 meters. Okay. So from this figure, let's say look at the segment one. So the maximum size of one segment is 500, and maybe we can put in many devices, um, within the um, between each stations. But anyway, 2.5 like mega meters away. And then how to happen? Each terminator exists there, so we call this terminator. And then suppose if your institution's bigger than like 500 meters, then how you can expand that? That time we need to use the repeater. The purpose of using repeater is that to amplify the signal, because the electric signal comes in and it can be decreases. So decreased signal will be re um, that has the same voltage from the source. So if we use many repeaters, we can expand the length, more lengths. For example, if we put 5 segments, then the maximum covering distance could be 2.5 kilometers. Bigger than 2.5 kilometers is not good. So in that case, you need to um, use some kind of backbone network to send the signals. That's depend on when the collision happens. For example, the last station here, and from okay, let's say A station, and to, let's say, the G station. This is two stations, the farthest distance, almost like 2.5 kilometers. And then suppose that your signal almost arrive here, and that time the station G knows that there is no signal or to use the link. Then it start to um, send out some frames. Then we can say that there will be some collision, right? Collision happens. Okay. Then the jamming signal should be received up to here. That limit the the length of each land, how it far away from the longest distance between the longest node. That's depend on the data link speed. And now actually in CSMA CD, we use like 9.56 microsecond of slot. So to reach from here to the station A within 2.96 seconds, we need to limit the distance as 2,500 meters of length in a institution. Here are some way of implementation of Ethernet as a page. You can see this figure, page 371. Okay, so as I mentioned you that 10 base 5 is 10 megabit per second speed link, and base means baseband, no converting as analog or signals. So it use the digital signal to send out the data, and one segment size is 500 meters. So the transceiver cable maximum this length should be 50 meters. So we have like this the sharing link, and each stations is or each node can tap into this commonly use the link, and the length from the main link to the each node is only limited, less than limit. I mean 50 meters. How about 10 base T? This T means that the twisted pair. So two pairs of UTP cables are used there. Okay, but in this case, they use a baseband too. So, like usually, when we implement this kind of scheme, we usually use like curve, and then they have RJ45 plug there. So if you can, if you want to attach some node to the curve, then you can use two pairs of UTV cables. So with the RJ45 connector. And the implementation of the standard Ethernet is very easy because we have here the shared link, and if you can tapping from the shared link, you can expand as many nodes to the cables. Instead of the bus topology, now we are using more the star topology. For example, the hub is kind of the center of the star topology, and using the RJ45 connectors, we are implementing this kind of LAN structures. Maybe in your RTTC and schools, I guess, we will install LANs with the hub and the node attached to the hub with the star topology. So the legend of this diagram, maybe is any node or host, and this is hub, and these are actually the cable tabs, but for the coaxial cable. This is not my I mean used in many cases. Nowadays you are using twisted pair cables with hub. That is a more popular implementation method in the LAN structure in schools. One big issue of the Ethernet is how to prevent collision. Collision between node or host. Suppose if we have like 10 nodes here, and they are sharing one link. Okay. Um, the possibility of collision happens would be very high compared with different scheme. For example, let's look at this scheme. So we may separate, okay, five nodes as one segment, and then we use some kind of bridge, another network devices that's connecting separated LANs. What is the advantage of using bridge in a LAN implementation? In this case, the possibility of collision, okay, between five nodes will be less than the 10 nodes um, length. So it is better to use bridge to reduce the probability of possibility of collision of Ethernet. Think that maybe the RTTC, in your RTTC actually, if you have many LANs in your institution, probably you need some bridge or backbone network. But in your school, I guess we may not use the bridge in there. So, but I think you have to consider that if your LAN size is very big, or many nodes are attached to a common link, then how to reduce the possibility of collision between nodes. So in page 3.3 374, why we need to use the bridges for the Ethernet network. Especially in page 3.5, 10 nodes are divided into three uh, different domains of a network with bridging, so it will decrease the collision probability within the Ethernet. But actually, in that case, we need to think about to pay the bridge cost to install this kind of scheme in your organization.